This is CPE 133. What we're going to do in this video is describe the differences between digital and analog, and we're going to do so in kind of an intuitive manner. CPE 133, it's about digital design. So why are we learning digital design? Well, it's a way to solve problems, and what's good about this is digital design is kind of a computer-oriented method to solve problems, which is going to make it pretty fast and efficient. So digital design is all about digital circuits, which are electronic based. So I know this is early in your career, but should you be worrying about voltage if you haven't really been working with it? And the answer is no, and it's because it is digital. And so let's talk about that. So digital, you can look it up in the dictionary and get a fantastic definition, but it's always kind of confusing. The best definitions for digital are contextual, and quite frankly, I think they're more understandable when you compare it to analog, which is the other type of circuit out there. So why digital electronics? Once again, it's computer-oriented. Computers are considered digital circuits, although they have analog in them also. And certainly the other type of circuit out there is an analog circuit. We get down to the point of digital electronics versus analog electronics, and what we want to do is abstract away from the electronic definitions and talk about some more intuitive definitions of digital and analog. Digital circuits, they're nice because they operate only at two levels, which is high voltage and low voltage. So these are two discrete levels. They're always the same levels in a circuit. Now they could be different voltages, but there's only two of them. Analog circuits, in comparison, they operate at a high voltage and a low voltage, but they operate at every voltage in between as well. So this is considered continuous level or a continuous spectrum. So once again, digital, you got two discrete levels. Analog, you have a continuous level. So what we're going to do is look at a couple of examples here, and the examples are stairs versus a wheelchair, some shading, and then I got to make some noise with my instruments here. So our first example is the stairs versus a ramp. In this example here, we have some stairs. Now when you walk up these stairs, you're only ever at one of these levels, and if you look at this diagram here, there's 5 or 6 levels, and that's all you get. These are 5 or 6 discrete levels that you're at. Now you compare this to a ramp here. This looks like a wheelchair ramp, and as you go, if you ascend up this ramp, essentially you end up at essentially an infinite number of levels, or we'll say a continuous number of levels. So once again, this is the digital on the left side, the digital spectrum. This on the right side is analog. So we got an example of shading here, so let's go pop over to that. This is a cut from Adobe Illustrator, and what we're going to look at is the notion of digital versus analog in terms of shading. Okay, so here's our digital circuit here, and I have two choices here. It's either all white or all black. Those are the only two levels I get. Now the comparison is with analog, and I can click over this analog circuit, and I can look at those levels on this thing. These levels can be all the way white, can be all the way black, but as you can see, I can get pretty much an infinite number of levels in between. It's not actually infinite, but there's enough shades of gray in here that make it seem like it's infinite. So once again, the top one, you got 2 levels. This bottom one, an infinite number of intensity levels. Our last example here is of stringed instruments, and this is essentially fretted versus unfretted instruments, and this is kind of what I'm into, so I always make this example here. Essentially, in a stringed instrument, the frequency function of the string length, and as I move my finger up and down the fingerboard or fretboard or whatever it is, it essentially changes the tone. But when we have a fretted instrument, it changes it in steps. Unfretted instrument, it changes it in a continuous fashion. So let's look at that. So here we have my famous bass guitar here. It's not really famous, but the idea here is this is a stringed instrument and it's fretted. So each one of these frets here, it changes the tone. So the tone of a string on a stringed instrument is based on the length of the string, and these frets essentially change the length of the string in steps. So you can actually hear this, and what you're going to hear is a stepping of the tone. So it's not a continuous, it goes up and bumps and bumps and bumps. And so here we go. Okay, so let me pull out the other bass. Okay, so this is my other bass. It's actually a fretless bass, and so It doesn't have those frets on it, which means it doesn't have those discrete tones on it anymore. And so what it has is a continuous change in the tone. So as my finger moves up and down the fretboard. So if you listen to this, okay, no steps like you heard in the fretted bass. So in the end, we are dealing with digital, but we don't need to deal with voltages. The issue here is in digital, there's only two discrete levels, which is a high voltage and a low voltage, and we don't even deal with that. We deal with ones and zeros. As far as analog goes, we'll save that for another class.